Hi, this is Mr. Patch. We're going to do a test today dealing with the scientific method and making a prediction. We're going to form a hypothesis, test it, and then we're going to see how close to that hypothesis or how close we got to our guess. Let me try that again. Hi, this is Mr. Patch. We're going to be running through a lab activities today, a virtual version of one, and we are going to run through the scientific method. When we run through the scientific method, we're going to make some observations. So what we're going to do is we're going to observe. You might observe that I've got 5 jars here, all of different sizes, and we are going to collect some data about how much air they hold. So we have to measure the volume of the jars. This one's obviously bigger, but we need to know the exact volumes of them. They go from big to small, but what is the exact number of milliliters these containers hold? We're also going to collect some data about how long a candle will burn in those different volumes of air. So we're going to run through the scientific method where we make observations about the jars, collect the data about the burn times, and then we're going to form a hypothesis. I'm going to bring over another jar that we have not measured yet. And we're going to form a hypothesis about how long the candle burns in this jar before we ever measure it. We'll measure it, test our hypothesis, and see if our hypothesis is correct. And if we're off, we're going to measure how far we're off and form our conclusions. So let's go ahead and get started. First thing we need to do together is we need to have some way to measure the volume of the jars. You don't have a graduated cylinder at home, so we're going to do this part together. So I'm going to start off with this big jar. Probably it'll take a few different fills of water to fill up this graduated cylinder. The graduated cylinder holds 500 milliliters. So I'm just going to fill her up. And I'm going to tell you what we've got. So we're at 500. 500 is not going to be enough. Remember, what we're doing is we're trying to figure out how much air the jar can hold. How much air is how much volume there is in there, right? So really what we're doing is we're determining the volume of the jar. There we go. Here's 500 again. So now we're at 1,000 milliliters. It's going to take another one, isn't it? And $1,500, if it fills all the way. It does. This one, the next one I don't think will fill all the way. So I have to make sure I know where I start and where I end. I'm at the 500. And I want to go all the way to the top. Wow. That is right at the top. You know what? I filled it right to the top, and there's no water that's dripped out. We're right at the top. So we did that 4 times. We've got 2,000 milliliters, right? So you need to write that down. So the big jar is 2,000 milliliters. This is a mason type jar. People use it for canning things. Now actually, once I've got that information, I can just get rid of the water. I know we're in a drought. Sort of hate to waste it, but for the use of science. Now we're going to do the next one. It's a mayonnaise jar. So remember, you should have written down by now, we had 2,000 milliliters on the first jar, the biggest jar. It's a ball mason jar. The mayonnaise jar now. 500. Looks like it's close to halfway filled. No more. There we go. This one's going to be close to 1,000. That's all it's got. It's got just a few milliliters left in it. And let's see. And so 490. So the second one has 990. And that's the size of the jar. Some of you might be wondering, why can't we just look on the side where it says a quart? And that's usually how much that they put in on there, and not how much it can actually hold up to the very tippy top. Okay, this one over here is a peanut butter jar. Let's see what we've got for this. Tiny bit, about 5 milliliters left over there. So 495 milliliters for the peanut butter. 495. So the first step here, remember what we're doing is we are just finding the volume of the jars. This one doesn't have a label on it. It's not going to take very much. So we started off with 500. Let's see what we end up with on this one. And I've got left 200, 25, 50, 60, about 260. So that makes it 240 milliliters. That's the second smallest. For the sake of it being easy, I'm going to still fill this up to the tippy top here. There we go. And the last one. The last one says artichoke hearts. I started off with 500 milliliters in my graduated cylinder. And I'm bringing it down. Wow. It's really close to 300, so I'm just going to call it 200. So we had 5 jars. We went from the smallest to the largest: 200, 240, 495, 990, and 2,000 milliliters. Now you'd expect probably, if we were to set up a candle burn, you would expect them to burn longer in the big jar and shorter time in the small jar. Small jar has less air, bigger jar has more air. So that makes perfect sense. But we want to know something beyond that. We want to know exactly how long it burns, and we want to make an exact prediction, like how many seconds it's going to burn in some other unknown jar. Right down to the second. So we're not just going to say it burns longer or it burns shorter time. We're going to say, how long does it burn? And on this part, you're going to have to do the measuring yourself. I did the measuring for the volumes because you don't have a graduated cylinder at home. But you probably have a stopwatch feature on a cell phone, or if you don't have that, you have a clock, or if you don't have that, just count the seconds: 1001, 1002, 1003, 1004, and do your best to count how many seconds the candle burns in these jars. Ordinarily, when we do this in a regular classroom environment, you're doing all this stuff. And I'm sorry you don't get a chance to do it right now. As you know, the COVID's thrown kind of a wrench into a lot of problems on this. We're just going to do the best we can. That's okay. So I'm lighting the jar, or the candle, not the jar, the candle, and I'm going to put the jar over it. So stop the tape now if you're not ready. But if you are ready, what we want to do is I'm going to put the jar over it. We're going to figure out how long it takes for this thing to burn before it runs out of air. And I'm going to do this on my phone as well, so I can write down some of the information, but you should be doing it yourself. And I'm not going to tell you what it says on mine. So, ready, set, go. And I'm trying to hold down this, so I've got a piece of paper under the candle, or under the jar here, to kind of seal it. The paper is a little bit damp to provide a little bit better seal. And eventually, we are going to run out of air. When we run out of air, that candle is going to go out. So, it's been going for a little while. I will give you a time right now. I have about 31 seconds. 33. So if you're in that basic category, that means we're kind of well aligned. I can see some condensation forming on the inside. That's what happens when you have combustion. And we are coming up to a minute here. Now, that's a minute. And I think the flame is getting a little bit smaller. I'm still holding it down so no air can get inside. And as soon as I see that thing go out, I'm going to let you know. It's a lot smaller than it was. Out. When I said out, it was done. So, ordinarily we would do this multiple times and we would take an average, but we're not going to be able to do that here. We have to kind of run through things a little quicker here. I'm going to do the second jar. Remember, the second one over here was the mayonnaise jar. It was 990 milliliters. By the way, you should have written down what your time was for the burn time in that jar. If you didn't get that, go back and watch the video again and measure how long it took between when we put the jar on top and when I said that the candle went out. So we're trying to keep some things the same, right? Have the same sort of setup here for each thing, right? Same candle and so on. And I'm going to say ready, set, go. So once again, I'm holding down the top to make sure that air doesn't come in and out. I saw a little bit of bubbling that indicates that if I don't hold this down hard like this, that air will kind of either leak in or leak out and mess it up a little bit. So I'm trying to prevent that from happening. And it's getting smaller. Out. So that didn't last as long, right? But we don't expect it to last as long. When I said out, that meant the candle was out. So I'm setting this one on the side over here. I'm going to go through the third jar over here now. This is the peanut butter jar. Ready, set, go. This is a little bit smaller, so I would expect that it's going to burn for a little bit less time than the others, right? So we're going kind of in size order. Out. This one didn't have a label on it. I think I just said it was the second smallest. By the way, when you're recording your times, make sure you record them as accurately as you can. If you're just counting 1 second, 1001, 1002, 1003, take your best guess on that. But if you're on a cell phone that has a stopwatch feature, record it to the 100th of a second. The more accurately you measure it, the better our results are when we figure out how much error we have in our calculations here. So I'm getting mine ready. And we ready, set, go. Out. That didn't last very long, did it?
Hello, North Valley. This is just a 10-minute heads up. At 11 o'clock, all classified staff will meet in the commons.
Well, that's great to
Again,
hear.
classified staff, we will meet social distancing in the commons in 10 minutes. Thanks.
Well, somebody's getting social distance. Good for them. Here I am. And I'm getting ready for the last jar, the smallest one, the artichoke jar. Ready, set, go. Out. Remember those last two jars were pretty close in size, right? One was 200 milliliters, one was 240 milliliters. I got that they were pretty close in the time as well. Anyway, what we want to do now is we have to set up a graph. We're going to set up a graph with the burn times and also with the volumes of air that we measured for the jars. So burn time versus volume of air. So I've got a Google sheet for you, and you can use that and start filling it in, and we're going to look for a trend. So when we've got that, we'll come back and we'll do the final test here with a different size jar. We'll make a prediction on it before we ever actually do the burn time.